Hello, and welcome back to Genetics 311 module lessons. Today we are talking about developmental networks. This is our subject on the right, the cute baby thorny dragon, and to the left is the developmental network that may or may not develop spikes for our little guy. I like to think of developmental networks as a chain of events. If this thing occurs, then that can occur, but if it doesn't, we get different results. Promotion is like encouraging or allowing the next step to occur, but inhibition prevents the next step. In genetic terminology, whether the strain is wild type or mutant can change the appearance of this individual. Here's a little brief video drawing that hopefully helps to explain this process in different simple scenarios. This is the first developmental network without any changes. S promotes P, which inhibits I, which inhibits K, which promotes E, which then promotes spikes. Therefore, without any mutations, aka wild type, our little dragon friend can produce spikes. In a second network, P is mutated, so I can now inhibit K, which cannot promote E, which cannot promote spikes, and our thorny dragon does not produce spikes. In other words, P was inhibiting I from inhibiting the next step. I like to think of this as a cancellation of sorts, that is, until P was taken out of the game. Let's erase all that for another example. In a third network, I is mutated, so K can promote E, which can promote spikes. Like the wild type, our thorny dragon can produce spikes. Again, let's erase all that for another example. In a fourth network, I and E are mutated, so E cannot promote spikes, and our thorny dragon does not produce spikes. Lastly, in a fifth network, S and K are mutated. So K cannot promote E, which cannot promote spikes, and our thorny dragon unfortunately does not produce spikes. Transcription and translation are energetically expensive, so the thorny dragon doesn't want to do them unless it has to. In a theoretical situation where this large circle represents the whole organism's body and the smaller circle inside is perhaps an organ, it doesn't make sense to make spikes on the inside where it could hurt themselves, but the outside spikes help protect the individual from predators. Therefore, transcription and translation would be expressed on the spike cells located outside versus the cells on the inside.